In this video, we're going to start the KutaSoftware free worksheet under Infinite Algebra 1, and it's going to be absolute value equations. I'm going to do all the odd problems in this worksheet. So numbers 1 through 17, going odds, and then in the next video, we'll do 2 through 18, finishing up the worksheet with the evens. So our directions are to solve each equation. And before we do that, I'm going to give a quick review of what the absolute value is. So say you have a number line, and I ask for the absolute value of 2. That is equal to 2. The absolute value of negative 2 is also equal to 2. And what that's saying, the absolute value is the distance a number is from 0 on the number line. So here's the positive 2, here's negative 2. If we're looking at the absolute value of positive 2, that is 2 steps or 2 units away from 0. And if we're looking at negative 2, that is also 1, 2. 2 steps away from 0. You can also think of absolute value as converting a negative number to a positive number. So regardless of whether a number is positive or negative, the absolute value will always be positive. Now note that 2 can stem from both the absolute value of positive 2 and the absolute value of negative 2. Both equals the same number. That means that this 42 stems from the absolute value of negative 42 and the absolute value of 42. Both of those equal that 42. So that's saying that this 6m either equals negative 42 or it equals a positive 42. So we're going to actually solve for 2 equations. So let's solve the first. 6m equals a negative 42. What we're going to have to do is divide by 6 from both sides and get that m is equal to a negative 7. Now let's go ahead and solve for if 6m was the positive 42. If 6m is equal to positive 42, we're going to divide by 6 and get that m is equal to a positive 7. So that means that m equals a negative 7 or m is a positive 7. Let's look at number 3 now. For number 3, we have the absolute value of k minus 10 equals 3. That means that this k minus 10 inside the absolute value is either going to be a negative 3 or a positive 3. So let's solve for when k minus 10 equals the negative 3 first. We're going to add 10 to both sides to get that k equals a positive 7. Now let's see when k minus 10 equals a positive 3. Add 10 to both sides, and we're going to get that k equals 13. So the answer for number 3 is that k is equal to either 7 or 13. Because 7 minus 10 gives us negative 3, and the absolute value of negative 3 is 3. And 13 minus 10 gives us positive 3, and the absolute value of positive 3 is equal to 3. Moving on to number 5, we have the absolute value of 7 plus p equals 7. That means, again, that this 7 plus p is either equal to a negative 7 or a positive 7, since the absolute value of negative 7 equals 7 and the absolute value of positive 7 equals 7. So solving for when 7 plus p equals negative 7, subtract the 7 from both sides to get that p is equal to negative 14. Now solving for when 7 plus p equals a positive 7, if we subtract 7 from both sides, we'll get that p equals 0. So for number 5, p is either negative 14 or 0. Both answers are correct. Moving on to number 7, we have 7 times the absolute value of n equals 56. This is a little different than the previous problems because this 7 is outside of the absolute value. So what we need to do is divide by the 7 first so that the absolute value is all by itself, so that we know the options for what's inside that absolute value. So dividing by that positive 7, we're going to get that the absolute value of n equals 56 divided by 7 is 8. Since 7 divided by 7 is 1, and anything times 1 is just that quantity that was multiplied by 1, which was the absolute value of n. So now we have the absolute value of n equals 8. That means that this n is either a negative 8 or a positive 8. And that's the answer for number 7. Number 9, again, like in number 7, we have a value outside of the absolute value. So we're going to start by dividing by this negative 3. Now we have the absolute value of p is equal to negative 12 divided by negative 3 is a positive 4. So since the absolute value of p is equal to 4, we know that p can either be a negative 4, since the absolute value of negative 4 is equal to 4, or p can be 4, since the absolute value of 4 is also equal to 4. In number 11, we have the absolute value of n plus 1 equals 2. Adding 1 occurs outside of the absolute value, so we're going to need to subtract 1 from both sides. That's going to leave us with the absolute value of n equal to a positive 1. And since the absolute value of n equals a positive 1, this n can either be negative 1 or it can be a positive 1 for number 11. For number 13, we have the absolute value of a minus 5 divided by 8 equals 5. We need to get this absolute value quantity by itself so we know what the possibilities or what the options are. So we're going to start by multiplying by 8 over 1, which is the same as multiplying by 8. And whatever we do to the left, we do to the right. The 8's will cancel out, since 8 divided by 8 is equal to 1. And the absolute value of a minus 5 divided by 1 is simply the absolute value of a minus 5. So we have the absolute value of a minus 5 equal to 5 times 8, which is 40. Now we know, since the absolute value of a minus 5 equals 40, that this a minus 5 within the absolute value equals negative 40 or it equals a positive 40. When what's inside the absolute value equals negative 40, so a minus 5 equals a negative 40. When we add 5 to both sides, we get that a is equal to a negative 35. So that's one possibility that a is. The other possibility is when a minus 5 is equal to a positive 40. When we add 5 to both sides then, we get that a is equal to 45. So our two options are that a is equal to negative 35 or a equals a positive 45 for number 13. For number 15, we have the absolute value of 7m plus 3 equals 73. We're going to start by subtracting that 3. When we do this, we'll be left with the absolute value of 7m on the left-hand side and the 70 on the right-hand side. So now we can look at what's inside this absolute value all by itself. So the absolute value of 7m equaling 70 is saying that 7m equals a negative 70 or it equals a positive 70, because either one, when you take the absolute value, equals 70. So looking at it when 7m equals a negative 70, we're dividing by 7, and we get that m is equal to negative 10. If we're looking at it when 7m equals 70, where that 70 is positive, when you divide by 7, you get that m is equal to a positive 10. The answer is either negative 10 or positive 10. And lastly, for this video, we're going to do the last odd problem, number 17. But before we do that, please remember to like this video, subscribe to my channel, and if you have any questions, please feel free to comment below. But hopefully now that you've liked this video, let's go ahead and go over the answer for number 17. We're going to start by multiplying by an 8 over 1, which is multiplying by an 8. And we're going to do that to both sides. So 8 divided by 8 is really a 1. So we'll be left with negative 9 plus v, and the absolute value of that quantity equals 3 times 8, which is a positive 24. So in doing that, we know that negative 9 plus v either equals a negative 24 or it equals a positive 24, because the absolute value of either of those quantities is that positive 24. So doing the math for when negative 9 plus v equals a negative 24, we're going to add 9 to both sides to get that v is equal to a negative 15. Now, doing it for when negative 9 plus v equals the positive 24, adding 9 to both sides, we get that v equals 33. So for problem number 17, v is either negative 15 or a positive 33. And that finishes up this video. Go ahead, continue on to the next video for the even numbers on this absolute value worksheet. In this video, we're going to do the even numbers 2 through 18 on the absolute value equation worksheet. I'll leave a link in the description below of how to get to that through the KutaSoftware website. So for number 2, we have the absolute value of negative 6x equals 30. That means that this negative 6x is either negative 30 or a positive 30. That's because the absolute value of either of those is equal to that positive 30. So first we're going to do the math for when negative 6x equals a negative 30, and we divide by negative 6 on both sides to get that x is equal to a positive 5. Then we're going to do the math for when that negative 6x equals a positive 30. Dividing by negative 6, we're going to get that x equals a negative 5. So for number 2, x is either equal to a negative 5 or it's equal to a positive 5. And those are the two options that variable x can be. Let's move on to number 4. Number 4 says the absolute value of x divided by 7 equals 3. That means that this x divided by 7 is either equal to a negative 3 or it's equal to a positive 3. So when x divided by 7 equals a negative 3, we're multiplying by 7 over 1, or simply 7, to get that x is equal to a negative 21. If we assume that the x over 7 is equal to a positive 3, when we multiply by 7 over 1, we get that x is equal to a positive 21. So for number 4, we have that x is either negative 21 or positive 21. For number 6, we have the absolute value of negative 3p equals 15. So we're saying that negative 3p equals either negative 15 or a positive 15. So if it equals a negative 15, we're going to get that p is equal to a positive 5. If negative 3p equals a positive 15, when we divide by negative 3, we're going to get that p equals a negative 5. So in the case of number 6, p is either negative 5 or positive 5. In number 8, they switch it up a bit, and they have the absolute value of m divided by 5 equals 3. We need to isolate this absolute value of m so we know the options m can be. We do this by starting with multiplying by 5 over 1 to each side. Doing so, the 5's will essentially cancel out because 5 divided by 5 is simply 1, and we know that any quantity over 1 is just that original quantity. So we'll have the absolute value of m on one side equaling 15, on the other. So now we know that this m can either equal a negative 15, since the absolute value of negative 15 equals 15, or it can equal a positive 15, since the absolute value of positive 15 is also 15. Moving on to number 10, again, we need to isolate that absolute value of m. So we need to get that by itself, and in order to do that, we're going to start by subtracting a 2 from both sides. That'll leave us with the absolute value of m equaling a positive 9. Since the absolute value of m equals 9, that means that this m is either equal to a negative 9 or it equals a positive 9. Moving on to number 12, we're isolating this absolute value of x. We're going to do that by multiplying by 7 over 1 to get that the absolute value of x equals a positive 35. That means that x, that variable, either equals a negative 35 or it equals a positive 35, because the absolute value of either of those quantities is a positive 35. For number 14, we have 4 times the absolute value of n plus 8 equals 56. We're going to have to start by dividing by that positive 4 on the outside. When we do that, we're going to be left with the absolute value of n plus 8. So we've isolated that now on the left-hand side, and that's going to be equal to 14 on the right, since 56 divided by 4 is 14. Since the absolute value of n plus 8 equals 14, this n plus 8 either equals a negative 14 or it equals a positive 14. So let's do the math for when n plus 8 equals a negative 14. We're going to start by subtracting from 8 on both sides to get that n is equal to negative 22. Now, when n plus 8 equals the positive 14, we're going to subtract the 8 and get that n is equal to a positive 6. So for number 14, n can either equal a negative 22 or n can equal 6. Number 16, we have x divided by 7. The absolute value of that quantity minus 8 equals a negative 7. We need to isolate that absolute value, so we're going to start by adding 8 to both sides. When we do that, we get that the absolute value of x over 7 is equal to negative 7 plus 8, which is a positive 1. Now we know that this x over 7, since it's the absolute value of that equaling 1, we know that that is either a negative 1 or it's a positive 1. So when x over 7 equals a negative 1, we're going to multiply by 7 on both sides to get that x equals a negative 7. When x over 7 equals that positive 1 option, when we multiply both sides by 7, we get that x is equal to a positive 7. So for number 16, x, the variable, can either be negative 7 or positive 7. Either is correct. And lastly, on this absolute value equation worksheet, number 18, we have negative 10 times the absolute value of v plus 2 equals negative 70. We're going to start by dividing by a negative 10 on both sides. That will help us isolate the absolute value of v plus 2 on the left, and a negative divided by a negative is a positive, so we're going to get a positive 7 on the right. Since we're taking the absolute value of that quantity, that's either going to equal a negative 7 or a positive 7. So when v plus 2 equals a negative 7, subtracting 2 from both sides, we get that v is equal to a negative 9. And when v plus 2 equals that positive 7 option, when we subtract 2 from both sides, we get that v is equal to a positive 5. So for number 18, our answers, or our options, that this variable v is equal to is either negative 9 or a positive 5. So with that being the last problem, please don't forget to like this video, and also please subscribe to my channel. That way, you'll be updated when I post new videos. Also, please feel free to comment below if you have any questions on the absolute value or a specific problem from your own homework that you need help on. But again, don't forget to give me a thumbs up on this video.